Let's now take a look at several examples. Determine the domain of each function. Write your answer using set notation and interval notation. Our first function is the rational function f of x equals 14x divided by 6x plus 7. Recall, rational functions are ratios of polynomial functions. And in order to determine the domain of a rational function, we want to focus our attention on the denominator. When you have a fraction or a ratio, you know that the denominator cannot be 0, because when it is 0, the whole expression is undefined. So in order to determine the domain of this function, we will take the denominator, 6x plus 7, and we will find all values of x that would make this denominator equal to 0. This is a simple linear equation, which we can solve rather quickly. We have 6x is equal to negative 7. X is equal to negative 7/6. X equals negative 7/6 is the value which makes this expression undefined. Therefore, the domain for this function is every number except negative 7/6, because when you take negative 7/6 and put it in the denominator, it will give us 0. And that's a bad thing. That will make our expression undefined. So let's express the domain of this function now using both set notation and interval notation. If I want to use set notation, I use these curly brackets, and I would say that the domain of this function is all x values that are elements of the real numbers. This might be new notation for you. This means element of, and this means real numbers. So we're looking for all the x values that are real numbers. And what about those x values? Well, they can be anything except one single value. X cannot be negative 7/6. Otherwise, x can be any real number. This would be the set notation for this domain of this rational function. Let's also express the domain in interval notation. In order to express the domain in interval notation, I like to first draw a number line. This helps me to set things up. X cannot be negative 7/6. So let's locate negative 7/6 on the number line. That's about negative 1 1/6, right? So let's just put it right here, negative 7/6. If this is negative 1 and this is negative 2. X cannot be that, which means there's an open circle at negative 7/6, but every other number is included in our domain, which we darken in on our number line, right? The set of all numbers except negative 7/6 would look like this on the number line. From the number line, we can then express the domain in interval notation. The interval notation, well, we first look at this interval here, and when we do interval notation, we take the leftmost endpoint and go to the rightmost endpoint. So this would be the set negative infinity all the way to negative 7/6. And this is open, so we use the open bracket to designate the end behavior at negative 7/6. This interval combines with the interval that's on the other side of negative 7/6, which is written as the open interval negative 7/6 all the way to positive infinity. This would be our interval notation for the domain of this rational function. So just to recap, when you have a rational function, to determine the domain, you want to find all the x values where the denominator is equal to 0, and then exclude those from our domain. The domain will consist of every other number except for those values. Let's take a look at the next example. Example 1b. We are to determine the domain of the function r of x equals x minus 7 over x squared minus 9x minus 10. Again, in words, the domain of this rational function will be the set of all x values that make this expression defined. So our job is to figure out where it's undefined, and that comes by setting our denominator equal to 0. Because we don't want the denominator to be 0, when it is, it'll make the expression undefined. So let's take our denominator, x squared minus 9x minus 10, and let's figure out where that is equal to 0. This is a quadratic equation, and the easiest way to solve this quadratic equation is to factor. X squared minus 9x minus 10 factors as x minus 10 times x plus 1, right? Because negative 10 times 1 is negative 10, and negative 10 plus 1 gives us negative 9. Now that we've factored, we can set each factor equal to 0 to finish solving. So that means x minus 10 equals 0 or x plus 1 equals 0. So that tells me there's actually two values that will make this expression undefined. X is 10 or x is negative 1. These values have to be excluded from our domain. So let's write our domain in both set notation and interval notation. The domain of this function will be the set of all x values that are elements of the real numbers, such that x is not equal to 10 and x is not equal to negative 1. That's the set notation for this domain. Let's write the interval notation, and again, I use my number line as a guide. I have negative 1, and then I have positive 10. Both of those values must be excluded, so I'll put open circles there to exclude them, and shade all the other numbers on the real number line. All of these numbers are elements which can be plugged into this expression. Let's write the intervals that correspond to this graph. We go from negative infinity all the way to negative 1, open it up because we're excluding negative 1, together with the next interval, which goes from negative 1 to 10, that is all numbers in between negative 1 and 10, excluding them with the open brackets. And finally, the last interval would be 10 to infinity, all the numbers from 10 to infinity, open bracket again to exclude the value at 10. This would be the interval notation for the domain of this function. Moving right along, this brings us to example 1c. Determine the domain of the function q of x equal 8x cubed over 5 plus x squared. Just as in our previous two examples, we want to focus on our denominator, and we want to determine all the x values that would make this denominator equal to 0. So let's take our polynomial 5 plus x squared and set it equal to 0. Where does this happen? Well, this happens when x squared equals negative 5, right? When you bring the 5 over to the right side. To solve this, we'd use the square root property, right? We take the square root of the left side equals plus or minus the square root of the right side, and there's a problem here, right? This is not a real number. So what does that tell me? Well, that tells me that there is no restriction on x. There is no real value that would make the denominator equal to 0. You can see that. In order for this to be 0, this quantity here would have to be equal to negative 5, right? because negative 5 plus 5 is 0. And any real number squared will never be negative 5. So there's no exclusions to this domain. There's no numbers that we have to exclude. So we would say that the domain of this function is simply all real numbers. When you talk about it in set notation, it looks like this, the set of all x that are elements of the real numbers. And in interval notation, that's simply the entire number line, the set of all numbers from negative infinity to positive infinity. This would be the domain for this function.